Next up, we've got Paul Kirby talking about single district groundwater quality studies. Paul is the project geologist at Daniel B. Stevens and Associates Incorporated. Let's give it up for Paul.
Good afternoon. Might be a little loud. Testing. Good. I can walk around. That's much better. Sorry if you're watching online and I go off screen. I just need to walk around a little bit. Okay. Let's see. Let's get started. Where is my presentation?
I think they're loading it up back there.
Thank you. There we are. My name is Paul Kirby. I'm with Daniel B. Stevens and Associates. Here today to talk about single district groundwater quality studies. These are a couple of studies that we completed over the last couple of years with Fayette County GCD and Pecan Valley GCD. These were some really exciting projects that I got to work on. I had a great time meeting people out in the community and working closely with the districts to gather a lot of data. So these are some typical mission statements from different GCDs around the state. This is kind of what you'll see is related to the protection and the preservation and the conservation of aquifers or groundwater resources or groundwater reservoirs and the like. And it's fairly similar across the state. And we're all about managing our aquifers, seeing where the data, or seeing where the groundwater is, and making sure nothing is going to waste. So what does protecting groundwater mean? Well, most districts, as other presenters today have talked about, have desired future conditions. Well, all of them have DFCs. And the way they monitor those is with some sort of water level. And they'll check wells, take a look at drawdown. They're trying to meet, or not exceed their DFC over a set period of time. Far fewer are developing data sets of water quality. And what does everybody want to know when they go drill a well? They want to know how much water they're going to get, where it's going to be, and how good it's going to be. And so is there enough, and is it safe to use? This is, does that work? There it is, it's green. This is TWDB's, Texas Water Development Board's data. It actually, the end is about 2012 is when we pulled this. So this is the statewide historic water quality samples from TWDB. As you can see, not too much done in the 30s, 40s, and 50s. Quite a bit done in the 60s and 70s, which is when most of the numbered reports that many of you have were done, and then tapering off over time as TWDB shifts focus to larger scale projects and not so much high resolution water quality sampling. So for Fayette County, they approved their study in 2013 and we completed it in 2017. You can see they had a lot of samples done in the 1960s. That's when Report 56 was done for them. That was a well inventory with a lot of baseline water quality sampling and information gathered. Pecan Valley GCD, which is DeWitt County, they approved their study in 2014, concluded in 2018. They had a big event in the 30s, a big well inventory then, a little bit more in the 60s, but then the still declining trend of state collected samples over time. So what's the point of doing additional groundwater quality studies? Well, as you just saw, most of the samples were collected in the early part or the middle part of the 20th century. So it's now been a good 50 years since anybody's done any high resolution characterization of groundwater quality in the county or in the district. So getting new data is a good idea, especially with additional activities going on like fracking, uranium mining, things like that. So this establishes new baseline measurements that we can look at should activities of concern move into the county. And we can evaluate new data against the old data and take a look and see if anything has changed over time. So your basic project tasks, define the objectives, review the historic data, so on and so forth. Identify wells to sample, field work, analytical, and reporting. So for your project objectives, what aquifers are we going to look at? Which ones are we going to sample? And it depends which district you're in and which county you're in. For Pecan Valley, which is DeWitt County, that's almost entirely Gulf Coast aquifer, with maybe some deeper ones over on the western edge. For Fayette County, there are 7 different aquifers that you could potentially pull from in that county, depending on how deep your well is and where you are geographically. So that had to be vetted and evaluated. What are your sampling distribution goals? How many samples do you want? This gets into a cost-benefit analysis. As a geologist and as a scientist, I want a lot of data, but that gets really, really expensive after a while. So we have to balance the budget of the district versus what we can get out of it and go from there. And what water quality issues do you have, or potential issues you want to address? Maybe there's some problems with a coal-fired power plant in your county. Maybe you have a lot of fracking activity going on and you want to develop some specific analytical suites to evaluate this specific data. This is a table from the report for Fayette County. These are the hydrogeologic units that they have. At the base is the Carrizo-Wilcox, Queen City, Sparta, Yewa-Jackson Aquifer, the Gulf Coast, which is usually the DFC is set for the Gulf Coast, but it can be split into the Jasper and the Evangeline. And there's several alluvial aquifers around the county along riverbeds and creeks that are used by some well owners. Here's the aquifer locations for Fayette County. The entire yellow area is Gulf Coast, and this would be the Jasper outcrop here and the Evangeline on the eastern edge. This kind of bluish area is the Yewa-Jackson. Over here is the Sparta outcrop, and then Queen City and Carrizo crop out further to the west. And then all the dots on the map are the wells from our study, classified by which aquifer was sampled. Our sampling distribution goals, this is DeWitt County, so Pecan Valley GCD. And superimposed on the outline of the county is the Texas Water Development Board's state well grid. So from a cost-benefit analysis, we figured that the best way to do this, and this is what we did with Fayette County, and it worked well there, was to try and sample one well per aquifer per state well grid. So we reviewed the Water Development Board's data, and if that data seemed to indicate that there were maybe several wells in the state well grid that pulled from different aquifers, then we would try and get those aquifers. So for Fayette County, if there was a state well grid that indicated that there was a well screened in the Yewa-Jackson and maybe one screened in the Sparta, we would try and sample both of those. So that would be 2 wells in that grid. And so that was our sampling distribution goal, was 1 well per aquifer per state well grid. And then depending on the size of the county and how many aquifers are present, that'll give you your total number of samples you hope to collect. This is a map of the wells sampled for Pecan Valley. Pretty good distribution. The client was happy with it. We were happy with it. There's some gaps, but that's expected when you're dealing with private well owners. That's the way it goes sometimes. And then water quality issues to evaluate. So Pecan Valley specifically has a lot of fracking activity in this portion of the county, and Goliad County has uranium mining, so they wanted to evaluate some specific analytes here for fracking, and down here a different set for the uranium mining impacts or potential impacts. Analytical suites. So everybody got the same basic analytical suite. This was basically modeled after the Fayette County report, so calcium and magnesium, sulfate, total dissolved solids, dissolved silica, things like that, pH in the field. And then we would identify and develop additional analytical suites as needed, depending on the desires of the district and the desires of the public. So for Fayette County, they specifically wanted to look at TDS lines. They are an ag county, so they wanted to add herbicides and pesticides. That's the SVOCs. And then public input, we ended up adding about 20 to 25 additional metals on top of what we were doing. For Pecan Valley, they were doing, they had the uranium mining and the hydraulic fracturing, so those areas got additional suites in there, and everybody got the general one. A historic data review, looking at the geology and the hydrostratigraphy, which aquifers are present, where is the outcrop, has dip been determined, or can you determine dip? That'll help you figure out if you have a well that's not assigned to an aquifer, but you know where the screen is, maybe you can assign it to an aquifer. What kind of historic water quality studies or data is available? Which wells have been previously sampled or water measurements done, and are there any other reports or sources of data that you can pull from? So we've determined our distribution, how many wells we want. Now we get to well selection, which can be somewhat problematic since they're almost all private wells. Since most districts have some sort of water level monitoring program, that should be your first stop, is to grab those folks and see if they're willing to let you come out and take a sample from their well, which unfortunately will be a very small number of wells in the district. So after that, it depends on how you want to approach it. For Fayette County, we developed a letter and an access form requesting a single time of access onto somebody's property to sample their well. For Pecan Valley, they actually ran an ad in the paper for several weeks, and that worked pretty well. They got a pretty good input on that and got quite a few volunteers to come out. We still ended up sending a letter to get more folks to come on board with Pecan Valley as well. So that's the contacting well owners portion for permission to sample. Keep all the forms, that way that you have it with you. The extensive PR is a little bit on the front side with like running an ad in the paper, but it's also important when you're out sampling that the PR doesn't stray, that you don't lose track of that. Many well owners will want to be there when you're collecting the sample. They all have questions. They like to invite you in for tea and Cokes, which is great, because it's usually in the summer when we're sampling, right, David? When it's good and hot. So going inside to take a break and answer questions for a local well owner is great work and great PR for the district and a consultant. And good, it's, works out well for everybody. So it's time to go sample. Do you recognize yourself, Mr. Van Dresser? You're welcome. David loves to climb windmills. And that's what you have to do, because every time we sampled a windmill, there was no wind. Here's some examples of sampling locations from both Pecan Valley and Fayette County. So here's your typical well house down here on the bottom right, filled with wasp nests, good times. Here's David taking a water level measurement. When we first started the program in Fayette County, we were doing some water level measurements initially, but what ended up happening is one of our field assistants would get a little overexcited and always started the well early, and so we never ended up getting any more water level measurements. And then there's a cattle trough, so you grab the sample, obviously not out of the trough. This is a pump here. It's hard to see, but it's from like the 1920s or 30s, so it was really cool. And then here's a windmill that's going to a cistern. Hey, Wendy. Sampling protocol. So we did the same protocol for every single well. We purged the well for 15 minutes. If you have a garden, we're happy to water it or let the water run wherever you tell us to. Collect the samples directly from the faucet closest to the wellhead, upstream of any treatment type of appurtenances. So upstream of iron filters, upstream of RO, upstream of water softeners. We don't want any of that interfering with the raw water sample. Preserve, label, seal, and store on ice and deliver to the lab. This is an example from Fayette County. So these are our samples that we pulled. They're all labeled, as you can see. There's custody seals that are signed and dated, and they're ready to go into a Ziploc bag and be delivered to the lab. So then the analytical results start coming in. So what does a consultant do with that? Well, the first thing you do is you start looking at analytical QA on the report to see if there is any flags or any excursions on the data that would result in some sort of odd bias in the detections, if there are any. And then you look at the actual data to see what got detected. Is there anything there that you don't expect? And if there is, then it's time to start looking at confirmation sampling. Can we assess this data by aquifer? Let's compare it to drinking water standards in rural. Let's compare it to the historic data and studies that have been done in the past and see if we can take a look at any geographic trends. A little bit about drinking water standards. I don't know how many of you are familiar with them or are water operators. I'm a water operator, so I have to know them. There's two drinking water standards in rural, primary and secondary. The primary drinking water standards are maximum contaminant levels set by the EPA. These are legally enforceable limits. If you're a public water system, they don't apply to private wells, but it's a good set of standards to take a look at your data against. The secondary standards are mainly aesthetic related, so taste and color and odor of water and things like that. These are not enforceable. Again, they only apply if you're a water system, but it's nice to know what the legal limits are so you can compare your data to that. So here's the primary drinking water standards out of rural, or at least some of them, listed here on the left, and then here's their MCL on the right. For these two particular counties, the ones that we expected to see exceed were nitrate and arsenic, and that happened in several cases, but those are known issues within the counties. There were a few other excursions, but nothing terribly concerning. These are the secondary drinking water standards. Again, these are the aesthetic ones. And again, for these counties, what would you expect to see? You'd expect to see chloride, iron, manganese, sulfate, and TDS, and all of those exceeded at one point or another. Comparing them to historical results, pulling the water quality data from the Water Development Board. Back when the Water Development Board had the database online, this was much easier to do. I think it's a little bit harder now. And then taking a look at any other studies that have been done to see if you can compare to that. So this is from Fayette County. This is some of their primary analytes. Here is the range of data in the middle here for the Texas Water Development Board's data set, and then overall on the way on the right is the range from the Fayette County study. Nothing really jumps out, which is good. Everything is pretty much within range of what historically has been seen in the county by Water Development Board sampling. There's a few things like iron is a little high, but again, not terribly unexpected. This is another table that we provided to Fayette County in the report and to well owners. Here's some more primary analytes. And here are the drinking water standards, if there is one set for each one of these, the range of data from the study, and then the number of samples from the study that exceeded either the primary or secondary drinking water standard. Just kind of a curiosity thing to see how many exceeded. Like I mentioned, we had numerous analytes exceed applicable drinking water standards. Arsenic and nitrate for primary, not unexpected. TDS, chloride, sulfate, iron, and manganese for secondary, not unexpected at all. Other analytes were sporadically exceeded, and anything that was really out of order got thoroughly investigated. And that's where confirmation sampling comes in. So if something comes up in the lab report that you don't expect, the first thing you do is contact the district, who contacts the well owner, and you go right back out and you sample again as quickly as you can. Generally speaking, the well owner is justifiably concerned if they have, for example, a detection of gasoline range organics in their domestic well or something like that. So you go back out, collect a sample, and see if you can confirm it. Sometimes it's a lab error, sometimes it's just a fluke, and other times there might be a confirmation that you have to then address. Taking a look at geographic trends, we tried to look at geographic trends for both districts. Fayette County specifically wanted us to attempt to determine the down dip 1,000 milligram per liter TDS lines, since that's the easiest measure of water quality as far as all these analytes go. Pecan Valley, we were not really able to discern a trend, and you'll see that here in a second. This is the historic TDS data for Pecan Valley. Blue is fresh. Anything other than blue would be slightly saline, and you can see it's pretty much fresh throughout the entire county. This is the current study for Pecan Valley, and it's a very similar map. So different shades of blue for freshwater. Anything other than blue is slightly saline, and it's pretty fresh throughout the county with little areas of slightly saline water. For Fayette County, I have a couple of maps here of some of the work we did. This is for the Jackson Aquifer, and it's hard to see for you guys. Maybe in front you can see it, in the back you probably cannot. Each dot is a well. Each well is labeled with its total depth, if we knew it, and then there is another number on top that would be the total dissolved solids number. We had a couple of areas where we estimated that it was greater than 1,000 TDS for the Jackson Aquifer, but for the most part it was fresh water to the extent that the data is available to see. This would be the Yewa Formation, so far fewer samples. This was our 1,000 milligram per liter TDS line estimated, so everything mostly to the west of that line would be fresh. Everything to the east would be saline or brackish, with the exception of this one area right here where we had a set of 6 or 7 wells, all of which were greater than 2,000 milligrams per liter TDS. And we never were able to determine exactly why, and it could be data limited, it could be something else, but that was one little area we blocked out for them. So in summary, we successfully sampled 277 wells in Fayette County and 164 wells in DeWitt County over 3-year periods. For both groups, we had good distribution of wells across the entire county. We didn't get the ideal 1 well per aquifer per state well grid because in many cases the well we wanted to sample isn't there anymore, or the well owner says no and they won't budge, or there just isn't access to that particular aquifer because nobody has a well deep enough anymore. Results were generally in line with Water Development Board data, nothing too surprising. But what's really critical here for for groundwater conservation districts is establishing data sets like these now and going forward into the future to expand the number of wells with historic data. So the previous studies were done 50, 60, 70 years ago. Most of those wells are long gone, and nobody's really doing a lot of stuff now. Like I mentioned earlier, the state is focusing on larger projects, and high-resolution studies like this aren't really being done anymore. So it falls upon the districts to try and get this stuff done themselves. Like I mentioned earlier, a few wells above the primary drinking water standards, arsenic, nitrate, chromium, fluoride, things like that. Numerous wells above the secondary drinking water standards. None of this was particularly unexpected, and if it was, we did confirmation sampling for it. So like I was just saying, significant groundwater quality data collection is being done mostly by, well, at a large scale by the state, at a small scale by not many. So if you have issues in your county that people are concerned about, whether that's encroaching fracking activity or maybe somebody gets a uranium exploration permit in the middle of the county and well owners are justifiably concerned, you can design a small-scale study to go take a look at that, or even better, do a large-scale study like this, grab the entire district, sample over a period of time to spread out the costs, and now you have a brand new data set that you can compare future potential issue data against. And I guess that's it. Are there any questions? None? Yes, sir.
Were there any particularly focused issues in either of these counties that led to this effort, or was it just a desire to nail down the baseline against what future changes might occur?
So in Fayette County, the district and I had started discussing this probably in 2010. And the board got a little bit involved, and one of the board members said that in his particular precinct, there was a large concern with the closed ash ponds at the Fayette Power Project coal plant. So instead of doing this type of study, we shifted focus to do a groundwater investigation around the coal plant to the extent that we could. And took a look, didn't find anything, and then shifted focus back to this. But that type of study, plus a uranium exploration permit that had been issued in the very middle of Fayette County, got the interest of the board and the public, and so everybody got behind it, and we were able to conduct this study. For Pecan Valley, that wasn't originally my project. I inherited it. I think they wanted to do a study because of the huge amount of fracking activity that was going on down there. Back in 2011, 2012, the fracking industry was going nuts in DeWitt County. And so there's wells everywhere. And they were concerned about that, plus the uranium stuff going on in Goliad County. So they had some specific issues they really wanted to investigate. So they put out an RFP, and we won the bid and then did the sampling for them. Anything else? Yes, sir?
Yeah, when you purged the wells, did you monitor any?
We didn't monitor as it was ongoing. We did. We just did a 15-minute purge, just as a standard. We did take pH and conductivity and temperature data and recorded that in the field book, and that was also provided to the district, but not as an ongoing parameter. Other questions? No? Okay, thanks very much.